Alrighty now, then still setting up. Hey folks. Oh, that's always funny when you do that. That was always so funny as a kid. Probably won't watch. I will still watch the chat room. Just maybe not as quickly as normal. Hey, Major. Ironically, Major, I've talked to two other developers today, and one of them was in Hungary as well. Let me just go ahead and get started. So, perfect, awesome timing. When I scheduled this, I didn't realize that JetBrains had their live streaming of it today, and I'm sure they have a lot of great content. We'll get this reported for posterity for other folks. The reason this came about was a couple weeks ago. I was, kind of glancing at my LinkedIn feeds, and somebody that's big in the source community posted, "Oh, eventual consistency is no big deal. It's easy. All you have to do is XYZ." And it's not easy. It's not necessarily obvious. So I thought it would be good to talk about where it comes into play, what tools Marten and Wolverine have for it, and maybe what we can do to ameliorate the challenges. If you're looking for a lot of UX advice, other than getting into WebSockets integration with the Critter Stack, I don't know. I think that sounds really hard. I think you should go find people who are much more knowledgeable than me. But just so you know right off the bat whether you want to watch this or not, things I want to talk about: what is eventual consistency in the whole? Talk about eventual consistency between modules, places you might want to use eventual consistency for performance or decoupling services. I would like to take a little bit of time to kind of review how the transactional outbox works in Wolverine, because it is somewhat different than a lot of the build your own outbox articles out there, and that's causing some trouble for users. Let's look at asynchronous projections in Marten. And then with all of that stuff, let's talk about how can we get non-stale data when we need to, where there's automated testing support specifically for eventual consistency, because that's an irritation. And then if time permits, we're going to look at some of the new SignalR integration into the Critter Stack and how that could help you, how you could pair that directly to asynchronous Marten projections for a better UI experience. Let me glance at just flip around to everybody. All righty. Okay. So with eventual consistency, what this means, but still focus on the consistency, rather than making it right and seeing the changes made and reflect immediately to downstream read databases. Like maybe you're writing a piece of data that has to impact multiple systems. Instead of saying we're going to do a distributed transaction, which for younger folks you don't want to do. That was a nightmare when we still tried to do things like that. But what's going on is data is not necessarily synchronized immediately. But the second point is still really important. We still need to guarantee that it will eventually be consistent. As a bad example, if you make a payment out of a banking account, and you deduct it immediately, and maybe down the line something will guarantee that you actually did have the balance and correct the account balance. You probably wouldn't do that. You would want strong consistency. Let's talk about some other places. So here's an example. This came from my previous employer. At the time, this was medical. It was analytics on medical data, but there was an application, and not giving away any real business logic here, but there's an application that was constantly taking in a lot of writes from a mobile app, a real simple mobile app, just recording the status of an ongoing medical trial. We wanted the people to be able to just very quickly go in, make a quick update, do their thing. On the very far side, on the read API, it was a very complicated model to build and view. There's a lot of logic to go from the little updates to what is the current status of this medical trial, who is everybody that's impacted, what are the next steps that have to take, what steps are late. It was also dependent upon what personnel were involved. The point is, from getting to the right API over here to making updates to having this read view be ready to view again was very expensive. In this case, one thing we could have done, we wanted to do to try to improve the system is we actually tried to calculate the whole read model right here. When you go to a different UI and ask, hey, I want to see all this really, really complicated model, and it would hang for up to a minute because it was so expensive to build. Instead, we could use eventual consistency here, allow writes to be fast, capture the data as fast as you can, apply those updates, constantly recalculate the state of the world in a background process. When the read people come to it, they would be looking at a pre-canned snapshot of that asynchronous projection. And maybe it wouldn't be completely up to date based on there would be some outstanding writes, but it would be good enough to be able to direct the work of the people that were looking at this. But we can keep this read API really snappy and fast because all the really hard work is happening in a background process. So that's kind of an extreme example of where some eventual consistency might be valuable to improve the throughput or just the perceived snappiness of your system. But this does come up. Of course, another case, now that everybody wants to do modular monoliths, and we've already been doing microservices for about 10 years, but let's be cooler and say modular monolith. And we capture some kind of action in module 1. And that is going to make an update to its state, its data. But that might also cause an update to, or it might require module 2 to take another action. So we're going to publish an event message, whether it's domain event, how you do it. I mean, obviously you're going to use Wolverine if you're listening to this talk. But the point is, we kind of want this a little bit decoupled. We want the action in module 1 to succeed. We want it to be relatively quick. We don't want module 1 to be tightly coupled to whatever's happening in module 2. We don't even want to care that it's in the same process. So by publishing an event, we got a couple things going on here. One, we're not doing it in a distributed transaction. So the module 2 changes are going to happen downstream a little bit later, but we need to guarantee that absolutely nothing gets lost and that this message that gets published will be won't be lost, will get processed later. So it's the next thing we're going to get into. We're going to start talking about the transactional outbox for durability to add some guaranteed to your eventual guaranteed consistency. But just kind of thinking about the decoupling, it will help you build a more resilient system if your downstream modules. If there is no direct coupling between module 1 and module 2, such that module 2 could be completely unhealthy, it could be broken, it could be down, module 1 could still function, and this outgoing work is being queued up, so it won't be lost. By queuing things up, maybe sometimes module 2 will be able to race ahead, maybe it'll fall behind, but you'll allow module 2 to run at kind of a steady state, maybe, where it won't get choked on bursts of data. And then this also gives you independent retry loops. So that's something really important too. The module 1 action can succeed or fail and stop the whole thing. Publish on the module 2, you have a completely separate retry loop. If something's wrong with module 2, retries may be kicking in, but you won't impact module 1. So just to sum that up, This is another place where eventual consistency might be valuable, even though it's a little more work to troubleshoot sometimes. Um, this allows module 1 and module 2 to be a little more independent, and this will hopefully make your system more resilient overall. Yay! All right, so we'll look at a real simple example, the transactional outbox. This has been such a huge topic the last 5-10 years. I bet you've run across this concept. And even if you use this Wolverine, I still wanted to kind of walk over this again. Wolverine's outbox is just a little bit different. Well, let's kind of kick into this with a code example. So let's say we are using Wolverine, and in this case, we're going to use EF Core. We're going to start pretending that you're not using Wolverine HTTP. Let's just look at an old MVC, classic MVC controller. That's what we got here. So if I take in a create item command, this is really simplistic. I am going to persist the new item, and then I'm going to publish a message to whoever cares that, hey, this item was created. So whatever actions take place later, maybe other modules kick on it, I don't know, but just it has to happen. So if we're outside we're outside the scope of a Wolverine handler or Wolverine HTTP, this IDB context outbox wrapper, this is trying to be a somewhat easier way to utilize the Wolverine outbox with EF Core not being inside of Wolverine. So just looking right off the bat, this is kind of a canonical example where an outbox is important. We're trying to persist this, and we're trying to publish a new message related to the thing we're trying to persist. And down here, you can see where we're trying to do it all together. What we need is both actions, the save and the publish, need to happen. They need to both happen together, or they both need to fail. If the transaction fails, obviously you don't want to publish this message. So inside this mode, just to kind of connect the dot, when you say publish async here, what you're really doing is queuing up, hey, here's a message that I want to be sent out after this transaction's commit. It's not sending it out directly because we're enrolled in a transaction. But it is routing it. It's just ready to go inside your outbox, this outbox service for this method to call. Ordering is really important. When this works, Wolverine is going to try to commit your transaction. So the database changes need to be made successfully. And then and only then will it kick out the message that you published here that refers to it. That's really important. If you don't have an outbox, what will happen to you is you'll get race conditions. You could get a case without an outbox. If I publish this item created message, it is actually possible that this could arrive at the downstream handler wherever it is, and it could try to process the item created method or the item created message before this item has ever been persisted to the database. When this is happening and you're not aware of these kind of race conditions, it can be a really wickedly hard problem to troubleshoot if you're not aware of these issues. And I say this coming out of experience because that race condition can absolutely happen. So one of the things the outbox does for us, a couple different things. It is making sure that everything succeeds or fails together. It is also making sure that things happen in the right order, that internally in this method, that it is saving the transaction, and only when it's successful does it try to kick the message out. And we'll talk a little more about the Wolverine outbox in just a second, because there's some important details I've alighted there. Alighted, however you say that. Coming down, this is another example of the exact same, basically the same functionality, but this time doing it in a little bit more newer Wolverine way. So same thing. I want to create a new item, and I want to kick out an item created message. This time I'm using Wolverine HTTP. So it has the transactional outbox mechanics completely built in. You don't really have to worry about it quite so much. So same kind of thing. It is technically inserting a new item, and also sending out a message that refers to the item all at one go. Okay. So, couple details I want to talk about with the outbox. So, the first thing, Wolverine's outbox, transactional outbox. I bump into a lot of users sometimes that get confused with the Wolverine behavior. They've read a lot of these YouTube creators out there are writing the roll your own outbox videos, and what they inevitably show is you automatically write every outgoing message to a table, and then a background process polls against the table. That is not how Wolverine works at all. It's also, if you want to build your own, it's also more complicated than what I think they let on. So maybe don't go try to roll your own unless you know what you're doing. Wolverine instead is store and forward. So in what that means in the code here, it is writing both the item created to the Wolverine outgoing table and persisting this all in one transaction. It's trying really hard to do it in the same database round trip by batching up database commands for performance. When this is successful, Wolverine is going to release the outgoing messages, all the outstanding kind of pending messages. Those are released to outgoing sending agents, kind of a background queuing process within your application themselves. It is going to try to send them as quickly as possible, and as soon as it has a successful receipt from the downstream broker or whatever it's publishing to, Rabbit, Kafka, whatnot, it is deleting the messages immediately out of the outbox table. So this is important. This is why I say it's store and forward. It is not really polling per se. What Wolverine is trying to do is it is trying to keep everything in memory with a backup copy to the database, and as soon as it's sent, it's deleting the record as fast as it can. All this asynchronous kind of stuff, there's always a trade-off between strict ordering and throughput, and Wolverine is optimized for throughput in this case. So there's not exactly a hard guarantee that messages will be delivered in the perfect order that they're written to the outbox, especially when there's different nodes. The last bullet point here, it is dependent upon message routing as well. This is something else that confuses people with Wolverine, causes me a little trouble. I want to look here a little bit. This item created, just kind of keep this in memory. So I'm going to go look. I'm going to do a description of this little application. There's something that's important here. So what I can tell is the item created message type is going to be published to the local item underscore created queue. Now, if I go down and look here, just a little more information, I can see that local item created is marked as durable. So this is important for Wolverine. Wolverine was built, I don't know if this is a good idea or bad, but Wolverine was built with the idea that you might want to mix and match heavier durable messaging with fire and forget messaging in the same application, and even possibly in the exact same operation. So whether or not Wolverine sends something to the outbox in the first place is on a message by message basis. So the fact that when it tries to route item created, it knows that should be going to a durable to a durable endpoint. So Wolverine will store it in the database as part of what it's doing. If I had instead made this fire and forget, and let's actually change it. So this right here, this line of code right there was what was making this everything be durable. So it was saying anything I publish to a local queue automatically needs to get, it's actually inbox for a local queue, but you get the point. So let's go back and check this now. Lots of warnings. And now we've changed item created is now buffered in memory. All it really matters to you is it's not durable. So the same bit of code we were looking at before, this is going to behave just a tiny bit differently now. With this being item created being routed to just a buffered queue, there is no inbox, there's no outbox, no inbox, nothing will be persisted. So point is, just be aware of that behavior, and then also the describe command that's kind of bundled in with Wolverine and Marten. That is your friend sometimes. Okay. Last point I want to make on the outbox. I said it's not exactly polling. There is a background process called the durability agent that's constantly scanning and looking for any messages that were recorded in an outbox or inbox, but the node that owned them has disappeared. Let's say you have an application that's working really hard. One node is very busy, and somehow or another it is killed. The process dies before everything is drained and done. That potentially leaves messages stranded in the outbox and inbox that node was supposed to be handling. The durability agent will come back after the fact. It'll see, oh, this node disappeared. I'm going to go recover all of its data, and it will recover the inbox and outbox messages to a different node. Again, no ordering guarantees, but your takeaway here, the thing that is most important is if your process crashes and messages are in the inbox or outbox that were in process, they will be recovered. They will fail over to another node. They are not lost. They will they will be processed eventually. All right. Let me check see. Okay. And hey, folks, thank you so much for being on the call. You guys ask questions anytime, even with our funny mirror thing. Okay. Kind of stepping forward, if you use Marten, and aren't those things ridiculously cute? You know that you can have some kind of projections running asynchronously, especially for any kind of projection where you expect there to be some kind of concurrency around when it is updated. You definitely want it running asynchronously. Maybe it's an expensive projection to do, so you don't want the cost of it updating happening as you try to capture rights. And then, I'm just picking off. There's more reasons than this. Another reason, Wolverine and Marten's combined ability to do blue-green deployments really depends on you using asynchronous projections as a way of kind of doing catch-up when you're rebuilding a new projection. Anyway, the point is, there's lots of reasons to use asynchronous projections with Marten. The downside is your data may be a little behind where you want it to be when you want to try to read it. And then, of course, your next problem is, what if you really do need consistent data now? So we still got tools for you. So I'm going to switch. I'm actually going to look at a little bit of CritterWatch code. I know we've been talking about that for what feels like forever. It's kind of a Duke Nukem Forever kind of release, but it is actually in process right now. So I'm going to show a quick example. Two small endpoints, or one small endpoint in CritterWatch right now. This is, for a little bit of context, CritterWatch is going to be a management console and observability platform for Critter Stack applications. So one CritterWatch instance could be inside of your organization, could be watching up to dozens of other services running. One point, part of the UI is going to need to say, I want to see a quick summary of all the services that are running. And this is going to tell you information about what version of Wolverine is this app on? Does it have Marten? Does it have Marten event sourcing? Are there dead letter queue tables that can be managed? Just basic capabilities of the system. But the service summary is built from an asynchronous projection that is constantly being updated as all your other Wolverine services are streaming in little bits of data of, hey, I started a node. I stopped a node. This guy moved around. This event projection progressed, whatever it is. The point is, this thing is asynchronous, is being built asynchronously. In this usage here, we're just streaming the current state of this as it's the current snapshot. But let's instead say what I want to do instead is I want the most up-to-date data for service summary right this second. So let's see this. So let's modify this real quick. Here's the rub. See the timeout that I'm specifying here. Just to make the compiler shut up. All right. What I'm doing here, because service summary is built from an asynchronous projection, so it's always being updated as more events come in, what I can do is say, I want to query for non-stale data of service summary. What this is going to do is the first time that you execute a query, it's going to reach out and see what is the high water mark of the event store for right now. And then it is going to be checking, it is going to wait until the service summary projection has caught up to that point in time, and then finally query for you. So it's going to guarantee that you get the very latest service summary data as of this point in time when you initiate the query. Let that one sink in just a little bit. Let me check questions real quick. All right. So it obviously comes with a little bit of downside. It's a little bit chattier. It's doing more back and forth, might be pulling a little bit to see if things are really ready. You're potentially slowing down your request and your web page loading. But on the upside, this will give you a chance to get the very latest data. And of course, I should also say this has the potential to throw an exception and timeout if it cannot, if the projection never catches up in that amount of time. So you have to be aware of that as well. This isn't necessarily something you want to do all the time, but it's been necessary and helpful for some Jasper FX clients, especially with more legacy code. But just so you know, this trick exists inside Marten today. This is something you're going to want to use occasionally. All right. 1 second, let me get this back out of here before we go on to the next thing. Let's look at another thing here. So this method here, just give me a single service, or let me give you a single service summary. A bigger one. This is a bigger view, but this is also being built through asynchronous projections. So this is streaming JSON. Just give me the current snapshot, whatever it is. It's absolutely good enough for what we're doing with Critter Watch. But let's say I want Critter Service to be absolutely consistent. We're going to be able to do this just a tiny bit different. Actually, I'm going to write a separate endpoint. Almost there, folks. Almost there. Okay, this version. This version, I'm using Wolverine tooling, but what we're doing is we're calling Marten's fetched latest API that's saying, give me the very latest, most consistent version of Critter Service. If the Critter Service projection is behind and this is running asynchronously, fetch latest will go get the latest snapshot. It'll also get any events that were appended to that stream after that snapshot, and it will advance it as necessary. The big takeaway is this is giving you a view of Critter Service that is completely up to date with all the events that have already been captured by the system, even if the projection is behind. Only works with single string projections. This is going to be significantly more efficient than what we did before with query for non-stale data. So just know this is something that's possible. It's usable. You can even use this on multiple streams at the same time in the same action. All right. Okay, no questions. Kind of moving on a little bit. Let's see what my time's doing. I might cut this one a little short, but let's talk about testing support in Marten. So this comes up all the time. This is something I have been actively helping clients with just in the last couple of days. There's actually some improvements coming in Marten, hopefully in a couple hours, to make this a little more effective. Let me just show you a little bit of what's going on. Happens all the time. I'm showing you some test code from within CritterWatch itself. Let me just find a better example. Sorry, folks. All right. So your big helper. This extension method is exposed on a lot of places. Doing something in a test where we are, constantly starting up a new iHost of a monitored application. And when this happens, I want the test harness to wait until we've received a message from the new node of, hey, I'm available, I'm up. And I want to wait for CritterWatch to have all of its asynchronous projections be completely up to date so I can start doing assertions immediately. This wait for non-stale projection data async. There's a couple different names on it. We have extension methods, same, just so you know, it's the same functionality on iHost, on Document Store, a couple other places in individual databases. Even though this does say projection data, it really encompasses every asynchronous projection or subscription that's happening. And like you would probably expect, this is going to wait until all the projection subscriptions catch up to what it knows to be the high water mark as it goes. Then you can proceed on to, now you know, okay, the point of this is now I know I can start checking the state of the database for assertions. So let's take this another way. If we're thinking about our normal, the AAA style of building automated tests, where you have an arrange where you're setting up all your inputs, and you have an act, you carry out whatever actions, and then you finally do an assert. Testing against any kind of asynchronous behavior is always difficult because you don't have easy ways of knowing when is the act really complete before I can move on to the assert. And that's what this wait for non-stale projection data is trying to do for you by just saying, I'm going to hold on until all the Marten projections of subscriptions running asynchronously are complete. I did mention there's a release coming up later today specifically to improve this. It's trying to add a lot more contextual information in the case that this fails. So if this times out, It's going to try to tell you as part of the exception message that comes out. It is trying to add more context of, well, here's everything that was running, and here's where the current state of everything is. So you could see, oh, maybe it's this subscription that was behind that never caught up. I'll focus on that. Similar to the Wolverine tracked activity testing, it is now also kind of listening during the course of wait for non-stale projection data. Sorry, folks. There's probably my four-legged coworker, I think, noticed there's probably a deer in the ravine behind me. Coming back to this. So during the course of this waiting and polling, it is digging in now, an observer of the asynchronous behavior. If any projection or subscription pauses or hits exceptions while this is running, if this times out, that's going to come out now into the output of the failure. So you have the goal here is to give you many more tools and a lot more information about what's happening in this asynchronous behavior, so that you have some ability to know, why did my test fail? Well, it turned out it failed because the async daemon hit a serialization failure on an event, which unfortunately happens. Or my projection threw an exception, and that caused the projection to stop and pause and never finish. But getting all that contextual information about your test failures, I'm hoping makes it a lot easier to diagnose test failures and to get on with your day. Questions. So, the eventual consistency with Wolverine, did cover this in a previous live stream on integration testing, but just to fill this out, let's look at this a little bit again. And I'm going to go to Critter Watch tests again. So, as you can probably surmise, this is a test that is trying to work on some of our ability to fetch dead letter queue information from a Wolverine application. So what's happening, just to give you a little more context, this is starting from a WebSockets client, because CritterWatch is going to very heavily use the new SignalR transport for WebSockets. We're going to send a message from a WebSockets client. So this is kind of a stand-in for the CritterWatch UI. We're going to track behavior across all messaging across any kind of external transports. And then I'm also going to track a couple extra things. We're going to test between a WebSocket client, CritterWatch in the middle, and a downstream Wolverine service that's one of the services being monitored. Ostensibly because testing service, just so you know that these are both iHosts. Testing service has been set up to have a whole bunch of dead letter queued messages in CritterWatch itself. Everybody, I think, is familiar with, we're going to set a big long timeout. And I'm going to send in a couple extra conditions. I want to wait, no matter what happens, I want to wait until we get this particular message back all the way to the WebSockets client. And then finally at the bottom of it, we're going to fire off a query and wait for everything to come back in this track session. So I know this is a lot, but just trying to show what's possible. This is setting us up to test between client process to CritterWatch itself, which is going to send other messages through some kind of queuing to a service that's being monitored. That service is going to send results back to CritterWatch. Hey, here's all the dead letter queue information. And that's CritterWatch is going to send a WebSocket all the way back over here. And this does it reliably. Now, this is just doing kind of a fancy request reply. What I hope you see from our test harness here is, let's say even if it's just a modular monolith, where you're capturing where you are capturing an event and you want to see it process a module. If you want to write a test that encompasses every single bit of this, the Wolverine tracked activity, that's what you need to use. That's going to be able to wait and detect, oh, I sent out a message. I'm going to wait until this message is completely processed. And if it triggers a second, third message, I'm going to wait until the system is complete, everything is done, and then I'm going to allow you to move from your act to your assert, and you can make assertions. But if you want to test the whole thing, the Wolverine track activity, that is your friend. And yes, folks, I spent more time on AI generated images than I did code samples this time. I don't have anything concrete to show yet, but kind of running into people that are doing a mix of testing with Wolverine behaviors that trigger asynchronous Marten projections or subscriptions, and maybe those Marten subscriptions also spawn something else. So you have this crazy cascade of actions, and people end up scattering a whole bunch of wait for non-stale data in their tests. A lot of repetitive tests. It gets kind of annoying. So I don't know exactly how this is going to work out yet or what we're going to do. What I'm thinking is maybe some extension methods. So letting Marten expose some extensions to this somehow, where you could also wait for Marten behavior. You could build in the Marten subscription and projection waiting directly into the tracked activity to try to do it all at one time. I don't know if it would be an opt-in or something maybe that's configured through the Wolverine application. That's something I'm still thinking about. If you happen to watch this video and this is something you might need, please feel very free to reach out through Discord or GitHub messages or GitHub issues and add any kind of context around this is what you need to do, or this will be helpful to you, or this is the usability you would like to have. So this just kind of kicked up yesterday from a couple Jasper FX clients. And it's something I'm just barely starting to think about. Hopefully something coming relatively soon. All right. Last concept I wanted to go through today. This will be worth a blog post on its own sometime. But Wolverine 5, that hopefully hits late this week, is going to add a SignalR transport. Not that you couldn't already have done this with a little bit of your own wiring, but I hope this is going to make it really easy to pump out SignalR messages directly from projections. So one of the ways, kind of getting into the UX side of eventual consistency problems, how do we deal with updating the client? We usually end up talking about WebSockets, and everybody kind of demurs with, "Oh, that's so hard. We have this existing application. We don't want to do that." But at some point, you probably do. I also talked to plenty of people that ask how to do this. So let's talk about how this could work. Show a little bit. Just to kind of show you that things actually do exist. So CritterWatch itself is going to be using the new SignalR transport. It just means we can actually send messages to SignalR. It's important, this marker interface here. This only exists to help routing. Just any message that implements this interface, we're going to do a SignalR to whoever's listening. Okay, so knowing that SignalR is in place. we talked about the service summary before. But now let's say that's actually a bad example. Here. This is what I want to see. So critter service is a much bigger state of a running system. And like, especially look at this information right here. What nodes are running, what agents are running on what nodes. So an agent in this case could be this projection for this database is running on node 1 or 3 or 5. This durability agent is over here. Maybe we have exclusive queue listeners where it's running on node 4. The point is, this could easily be relatively kind of ephemeral. It could be changing a lot during production. You would want to see this reflected on the screen sooner rather than later. Show you what we could do now. So switching over, critter service projection, single stream projection. It is registered inside of CritterWatch to be running asynchronously. That's important. So let's say anytime this updates from an async projection, let's see, maybe we want to have it shoot out a WebSocket update to our clients. Side effects. Hang on. Oh yeah, hey, look at there. There's even a to do. So let's say that we have a new message that's just critter service updated. It's going to carry the critter service, the new version of it. I'm implementing this interface that's strictly a marker that's just telling critter stack itself, hey, I want this to be sent to WebSockets through SignalR. All that's going to do okay, since raise side effects, we know what it's being updated to. And we can say why are we wanting? One second. Okay, so what we're doing now, this little bit of Wolverine and Marten working together in magic. But if you are bootstrapping your system with Marten and Wolverine and using the integrate with Wolverine option, it's kind of hooking together a little bit here. Raise side effects. As this is running asynchronously in normal mode, not rebuild, just continuous mode, every time a critter service is updated, even if it's 1,000 events being processed at once, critter service is being updated once, right after it's saved to the database successfully. This will actually send this new message as part of the projection. It'll send this through Wolverine. So Wolverine will happily route this to, in this case, it knows I send it via SignalR to whatever open clients are out there. We use array side effects. This is your mechanism to be able to push data from projections to projection updates to clients through SignalR. So hoping people like this. We're going to use it right off the bat with CritterWatch, so we'll dog food it. But this is something that people have asked about quite a bit over the years. So now Wolverine 5, tentatively tomorrow, probably more like early next week. But this will be the recipe out of the box now for doing SignalR publishing directly from a projection. Now, of course, you could have just called a SignalR hub immediately and tried to do it. But by publishing it through Wolverine, you get some extra stuff with it. You get potentially some open telemetry tracing. You get a lot of logging. More importantly, you get retries. So by letting Wolverine handle it, Wolverine will handle any problems and hiccups on the SignalR side, because the one thing you absolutely do not want to ever do is add any kind of potential destabilization to your asynchronously running projections. Because if a projection fails out, it just pauses and stops and then tries to restart in a certain amount of time. So we want our projections running clean. We want to get the side effect out. We're going to let Wolverine relay it to us. And then when I was little, very little, these Abbott Costello stuff, they actually had the super old reruns on like Sunday afternoons. They're probably like 50 years old even when I was a kid, but loved Abbott and Costello. All right, folks, that is actually all that I meant to get through today. A little goofed up, but any questions anybody want to ask while we're on the live stream? I'm kind of here for anything. And for our Hall of Mirrors thing here, it's October is about the first time in the year where it is cool enough to sit outside here in Austin, Texas. So I'm outside letting the dog prowl around the backyard, kind of enjoying a nice breeze. So that's why we've got the outside set up here. Well, folks, thanks everybody for coming. This will be recorded. Thanks, Darren, for coming on. Thanks for saying that. It'll probably be a couple weeks before I try this again. But the next time I do this, I want to do vertical slice architecture with Wolverine. So, folks, thank you for everything, and I will see you all soon.